Solar power is now a proven and reliable solution for water supply in humanitarian and development contexts, including during camp setup and the first phase of an emergency. Solar also contributes to the achievement of the Sustainable Development Goals and is environmentally friendly. The Global Solar and Water Initiative, with funding from USAID, continues to support governments and organizations involved in planning, designing, and implementing water infrastructure projects to mainstream the use of solar for water supply. Our work has included reviewing and analyzing over 200 water schemes, engaging with private sector contractors and technical offices from 10 countries, and conducting over 100 interviews with users. In the process, we have identified 5 areas that organizations should pay attention to. Quality solar modules can be particularly difficult to identify due to the huge variety of products in most markets. Verifiable certification marks help identify quality products. A technical review of quality should be done before other considerations such as cost. Some practitioners continue to falsely believe that solar pumping technology is expensive. We have used net present value analysis to compare the real cost of a water system across its expected lifespan. When operating and replacement costs, in addition to upfront capital investment, are factored in, it becomes clear that solar is cheaper than diesel in the long run, and in some cases from day one. Solar makes sense even in countries where diesel is cheap. By using economic analysis, implementing agencies can quantify the cost-benefit of solar, make decisions on which site to prioritize, and convince donors to support their solarization efforts. Water storage tanks are important to balance supply and demand in any water system. For a solar pumping system, water production varies according to daily and seasonal variations in cloud cover and solar intensity. This may result in the need for greater storage capacity to provide an extra buffer. It is a false economy to undersize storage, as it may result in the underperformance of the system and the need for water rationing measures to be introduced. More attention should be given to correct tank sizing. The notion that water supplied from solar should be free because the sun is free is still widespread. Over 2/3 of communities that have standalone solar systems do not pay for water. Implementing agencies should be aware that even though the operation and maintenance costs for solar-powered water systems are low and break down less likely, when problems do occur, costs can be high. Money should be collected to address failures and improve services, taking into consideration the context, water production costs, and affordability. Implementers continue to neglect management aspects of solar-powered water schemes, compromising their sustainability. Contexts vary, so there is no one-size-fits-all solution. But regardless of whether a solar scheme is managed by a community, NGO, public or private enterprise, a viable business model needs to be developed to cover operation and maintenance costs. At some point in the future, a major breakdown might occur, requiring a qualified technician to be contracted and a high-value equipment such as a pump or inverter to be replaced. Very few water schemes currently have such a business plan in place to meet these costs. The widespread use of solar power for water pumping is a win-win situation for water users, implementing agencies, donors, and governments. When properly implemented, putting into practice the various aspects of sustainability, it saves money, provides a more reliable service, and is good for the environment. The Global Solar and Water Initiative continues to increase knowledge and awareness of the benefits of solar pumping by developing and sharing relevant resources, including a book, an online course, a solar pumping toolkit, on-site solar courses, and the technical helpline that is freely open to all WASH agencies.